Now I am starting with a new topic, that is expected questions for the board exam and pre-board paper. So first I am doing for real numbers chapter. So now the first question says prove that root 2, root 3 and root 5 are irrational. This will be a 3-mark question if anyone is asked. So I am doing for root 2 the same way you have to do for root 3 and root 5. Instead of 2, you have to put 3 and 5. So let us start. So the first thing which I will do will be let root 2 be a rational number. So I am doing with the converse thing, that I am not taking it irrational, but I am supposing it as a rational. Therefore, root 2 can be written in the form A upon B, where A and B are co-prime and B is not equal to 0. Therefore, root 2 equal to A upon B. So, therefore, I can say B root 2 equal to A. Now, squaring both sides, I will have A square equal to 2B square. Now, so A square upon 2 will be equal to B square. So therefore 2 divides A square 1. Now using theorem, that is if prime number P and P divides A square, then P divides A also, where A is a positive number. Therefore 2 should divide A also. So I can say A upon 2 equal to C, where C is some positive integer. Therefore A equal to 2C. So therefore 2B square will be equal to 2C whole square. So 2B square equal to 4C square. So B square will be equal to 1 upon 2 into 4C square, that will be 2C square. So thus 2 divides B square also. This I am giving 2 number. Now using 1 and 2, I can say K2 divides both A and B. Therefore 2 is a common factor of A and B. Therefore A and B are not co-prime numbers. Thus our thus our assumption is wrong. Therefore root 2 is irrational. Now the same way you can prove root 3 and root 5 by putting instead of question 2 says the HCF of 85 and 238 is expressible in the form 85 m minus 238. Find the value of m. Here this question is also of 3 marks, and here first of all I will be doing prime factorization. So using prime factorization, if I do prime factorization of 85, I will get pi and 17 as prime factor, and if I do of 238, I will get 2, 119, and then 7, 17, and 17, 1. So 85 equal to 5 into 17, and 238 equal to 2 into 7 into 17. So HCF is 17. So HCF of 85, 238 is 17. Now writing HCF in terms of 85m minus 238. So I can say 85m minus 238 equal to 17. Now 238 I am taking on that side. So 85m equal to 17 plus 238. So 85m equal to 255. Now m will be equal to 255 upon 85. So that will be 3. Therefore m equal to 3. Now the third question says find the HCF and LCM of 480 and 720 using prime factorization method and verify the formula. So first using prime factorization method to find the factors. So 480, it will be 2, 240, 2, 120, 260, 230, 215, 3, 5 and 5, 1. And the other one is 720. So 2, 360, again with 2, so 180, 290, 245, 315, 3, 5 and 5 and 1. So I can say 480 equal to, and 720 will be equal to 1, 2, 3, 4 times 2, 2 times 3 and 1 times 5. So if you see carefully, 4 twos are common and 1 3 and 1 5 are common. So I can say HCF equal to 2 into 2 into 2 into 2 into 3 into 5. So that will be 240. Now to find LCM, what I will do? The ones which are already repeated in both, I will write one time. Now the 1 2 extra that I will write, then 1 3 is extra that I will write. Now 3 into 5. So that is coming as 1440. Now the rule says HCF into LCM equal to product of two numbers. So here HCF is 240 into 1440 should be equal to 480 into 720. So if I multiply, I am getting 345,600, and here also I am getting 345,600. Hence proved. Hence I proved that HCF into LCM. Question says prove that 3 plus 2 root 5 is irrational. So here also I am proving in the same way. First I am supposing it as rational. So let us assume that 3 plus 2 root 5 is rational. Therefore 3 plus 2 root 5 can be written in the form of A upon B, where A and B are co-prime and B is not equal to 0. So therefore 3 plus 2 root 5 equal to A upon B. So therefore 2 root 5 will be equal to A upon B minus 3. Now doing LCM on the RHS side, I will get A minus 3B upon B. Now if you see carefully, 2 is here extra, so I am taking that also from LHS to RHS. So from multiplication, it will go in division. So it becomes root 5 equal to A minus 3B upon 2B. Now, if you see, LHS is irrational and RHS is rational. But root 5 is irrational. Therefore, irrational can't be equal to rational. Therefore, therefore, our assumption is wrong. Our assumption is wrong. Thus, 3 plus 2 root 5 is irrational. Next question is find the HCF and LCM of 6, 72 and 120 using prime factorization. Again, this is a 3-mark question. So first, doing the prime factorization of 6, I will get 2 and 3. 72 if I do, so with 2 it will go, so 36. Again with 2 it will go, so 18. Again with 2 it will go, so 9. Then 3, 3 and 3, 1. Then 120 if I do prime factorization of 122, 60, 230, 2, 15, 3, 5, 5, 1. So I can say 6 equal to 2 into 3, 72 equal to 2 into 2 into 2 into 3 into 3, and 120 equal to 2 into 2 into 2 into 3 into 5. So 1 2 is common in all of them and 1 3 is common in all of them. So HCF equal to 2 into 3, that is 6. Now, if I want to find LCM also here, LCM will be 2 into 3 which are common in both. Now, the remaining common ones I will write 1. So 2, 2 and 3 and 5. So LCM will be 360. Now next question says HCF of 3 cube into 5 square into 2 comma 3 square into 5 cube into 2 square and 3 raised to 4 into 5 into 2 cube is 450, 90, 700, 630. This type of MCQ will be there. So now the easiest way is write HCF. First write all the values which are given 3, 5 and 2. Now, for the HCF, we have to select the minimum value out of all. So 3 is having 3 power, 2 power and 4 power. So it will be 3, 2 power. Then 5, 2 power, 3 power and 1 power. So 1 power. 2, 1 power, 2 power and 3 power. So 1 power. So this will be 3 square will be 9 into 5 into 2. So HCF will be 90. Now 7 question says if HCF of 420 and 189 is 21, then LCM of 420 and 189 is 420, 1690, 3780, 3680. So We know one formula HCF into LCM equal to product of two numbers. Product of two numbers. So now here three things we know. We know HCF is 21 into LCM I don't know, and both the numbers I know 420 into 189. So LCM will be equal to 420 into 189 upon 21. So if I cut 21 with 42, so it will be 20s are. So the answer will be 3780. So option C is the correct answer for me. Now next is assertion and reason. Assertion A says HCF of any two consecutive even natural number is always 2. Reason says even natural numbers are divisible by 2. Option A is both assertion and reason are true, and reason is the correct explanation of assertion. B1 is both assertion and reason are true, and reason is not the correct explanation of assertion. Third one says assertion is true and reason is false. Fourth one says assertion is false and reason is true. So here if you read the statement, it clearly explains us that assertion is true, that any two even numbers is always 2. Between them the number common will be 2. Both will be divisible by 2. And reason says even natural numbers are divisible by 2. So that is also true. So my A option will be right here. That is, both A and R are true, and R is the correct explanation of A. Ninth one says assertion 2 plus root 3 into root 3 is an irrational number. Reason, product of two irrational number is always irrational. So here I can't say that always the product of irrational numbers will be irrational, because root 3 into root 3 can be 3, but 2 into root 3 will be always root 2 root 3. So here I can say the C option is right, that is assertion is true but reason is false. Next question says explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So if you see carefully, 7 into 11 into 13 plus 13, I can do it like this, get 13 into, I am taking 13 common from both, so 7 into 11 into 1 plus 1. So this will be 13 into 78. So prime into composite will be always composite number. And same way, if I do for 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So if I take 5 common out, so I will have 7 into 6 into 4 into 3 into 2 plus 1. So that will be 5 into 1009. So here this number also will be composite. Thus, both the numbers are composite numbers. Now, next question, it says if two positive integers a and b are written as a equal to x cube y square and b x y cube, at where x and y are prime numbers, then HCF of a comma b. So, if you see, a is x cube y square and b is x y cube. So again, if I write HCF, so HCF of a comma b will be equal to, I am writing x and I am writing into y. Now, the lowest power of x is 1 and lowest power of y is 2. So, HCF will be xy square. So, B option is the correct option. Next is the number 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n will end with digit 0. So, for a number, let it be 4 raised to n. So, if I take prime factors, so I will get 2 into 2 whole raised to n. So, it will never end with digit 0. As for because for because for digit to end with 0, it should have 2 and 5 as multiples. So here both 2 and 5 are not there. So I can say it won't have any 4 raised to n will not have any number which ends with